I wanted to do a short or relatively short YouTube video on the interrelated um, topics of cosmogenesis and consciousness, and probably say something about spirituality in general, because obviously those topics impinge upon notions of spirituality, at least for many people. Um, I've lately had a couple of ideas, one on cosmogenesis and one on consciousness. um, that I've talked about on Facebook a little bit, but I haven't really elucidated it in a clear way. So, you could write books and all this stuff. And I'm not going to write a book here, but cosmogenesis is basically the field about uh, how did the universe begin? Did it even begin in the first place? So, models of, for example, the Big Bang Theory, the notion that the universe started in essentially a space time singularity, point of infinite density, and then expanded out from there. And of course, there's many variants of that. You have inflation theory, in which it doesn't start as a point of infinite density, but it starts very small, say the size of a proton, call it 10 to the negative 18 meters, and then it goes through a very inflationary expansion phase, meaning it very quickly expands in size uh, to maybe roughly the size of a beach ball or something like that in the first 10 to the negative 35 seconds, and then it assumes a more sort of gradual expansion phase that we're in now. And when I say the size of a beach ball, I mean the Hubble volume. I mean, it could be infinite size, but it just in terms of everything we can see in the telescope after 10 to the negative 35 seconds, uh, an inflation model was about the size of a beach ball. Okay, or at least the numbers that I read 20 years ago. Uh, but of course, that wasn't the only model. There's a steady state theory of Fred Hoyle in the 40s and 50s. And that was that basically there's a negative energy density in the vacuum of space time. And this negative energy density um, enables the nucleation of hydrogen atoms, because the energy density needs to be zero. So if the space time fabric itself is negative, it creates hydrogen atoms to sort of cancel that out and keep the overall energy density to be zero. Over time, these hydrogen atoms coalesce into galaxies that then move apart from each other because of this negative pressure. And then, kind of once it moves way apart, far enough apart, um, kind of the cycle starts over again. I mean, there's different versions of this, uh, but that was fell out of favor uh, for a number of reasons. That it would predict that the further away you look in the telescope, the density of galaxies are pretty much the same the further back you go, because obviously because the finite speed of light, the further you look, you're also sort of looking back in time. Uh, so if you look at a galaxy 10 billion light years away, you're also looking at it as how it looked 10 billion years ago. So the notion is that galaxies should be basically evenly spaced 10 billion years ago as they are now, if steady state were true. But if the Big Bang model were true, there's more of a density. They get spaced closer together 10 billion years ago. So those types of observations seem to support the Big Bang theory more than steady state. Um, and I'm not up on the details, but I believe Stephen Hawking did some theorems in the beginning of his career to show that uh, if relativity were true, basic assumptions of relativity, that was a singularity in the beginning, so that uh, steady state theory did not hold if you assume certain things about general relativity. Now, of course, reality might not match relativity exactly, and the fact that there's singularities probably shows that relativity might not be the final answer. Uh, so just because there's some uh, the Hawking-Penrose singularity theorems to show that there was a Big Bang singularity given certain assumptions doesn't automatically mean that there indeed was an initial singularity. It just all depends on your assumptions. Uh, but long story short, steady state theory fell out of traction. Um, and there's something called quasi steady state theory, which I haven't read about extensively, but it tries to have kind of a cyclical model where you start with galaxies close together, not quite at a 0 point, but closer together than they are now, and then they expand and they get to some sort of maximum, and then they can kind of contract again. And it's like an accordion; it goes back and forth ad infinitum. Um, now, uh, this is the quasi steady state theory is a nice sort of clean theory. I like it, but again, I can't say necessarily that it's been proved in any way. And again, you would probably have to, uh, and this is way out of my ballpark, but uh, I think if you wanted to promote quasi steady state theory, you'd have to find a way around the Hawking Penrose singularity theorems and so forth. So there's some technical encumbrances, but it is a theory that I quasi steady state. I kind of like it because it's nice and symmetrical and so forth. Um, the background radiation has often been touted as being a proof of the Big Bang, but also it could also support steady state theory because um, it's, I believe, something like 3 degrees Kelvin. I don't have the exact numbers, but the temperature of the cosmic microwave background radiation that is purported to be evidence of the Big Bang could also be caused by basically burnt out galaxies. So if you took all the hydrogen in the Milky Way and you burned it up over a long period of time, then however many billions of years later, what would be left over is sort of a black body radiation of about 3 degrees Kelvin. So the cosmic background radiation could be interpreted as being leftover radiation for the Big Bang, but it could also be made to work with steady state theory. And I think that that's kind of Occam's razor. The simplest explanation is the best one. Um, that cosmic background radiation may well simply be leftover radiation from very ancient galaxies. Uh, Now, there's always been a um, issue with this notion that the universe could have always existed because it creates a logical paradox of causal chains. If there's cause and effect, then that means you need an infinite number of causes for any one effect if the universe is infinitely old, right? So that's a logical issue. But it occurred to me, and I'm sure it's occurred to others too, but it just occurred to me sort of independently that temporal chains and causal chains are not necessarily the same thing. So if you imagine a pool table with billiard balls, now you can imagine that pool table with billiard balls have always been there. Um, and for eons, this pool table with billiard balls is nothing happens. And then there's some sort of quantum fluctuation, some sort of random event that gets the billiard balls in motion and they start hitting each other. And maybe they go around, disregarding the effects of friction. Maybe they continue to hit each other for billions and billions of years. And eventually they dissipate because of maybe entropy or something like this. Um, and eventually they kind of grind to a halt again. Um, Now, what is that? That's a causal chain. It started by some random fluctuation, and it created this cause and effect of balls hitting each other for however long, and then it kind of dissipates. And then, presumably, in the far flung future, there could be another fluctuation that gets them going again, right? But the point is, each cycle of the billiard balls hitting each other are independent causal chains. So, in other words, if there was a previous phase of the universe, a previous expanding phase, that would not causally or not necessarily causally impinge on our expanding phase. Right. So, again, people, philosophers, scientists, they get themselves tied into knots about how could the universe be infinitely old because you can't have infinite cause and effect. Well, you don't have to have infinite cause and effect. Uh, it could well be that our universe started with some sort of event, quantum fluctuation, that sort of got things going, and it was at a state of low entropy, and then it evolves to some state in the future of very high entropy, and it's sort of everything shuts down, and then that might stay that way for vigintillion of years, and then there could be some other fluctuation that gets things going again. Now, whether that's in the same framework as quasi steady state theory or not, I don't know, but it could be. I kind of like that, but again, I don't follow physics as much as I used to. So, but my point that I'm trying to make here is causal chain is not the same thing as temporal. In other words, you obviously need temporal chains to have a causal chain, but not all causal. Um, excuse me, not all temporal chains are causal. Meaning, if I have an infinite number of time towards the past or towards the future, I don't necessarily have to have an infinite cause and effect. So, cause and effect could be finite, even if temporarily the universe goes back forever. The chain of cause and effect we're in now may well be finite, started with the Big Bang, but it didn't go back forever, and it might end at some point in the future, even though the time goes forever. So the universe could be infinitely old to the past and to the future, but the causal chains are finite, and they're sort of kickstarted by, for want of a better word, quantum fluctuations. Uh, so I do now think that the universe is, in some sense, infinitely old temporarily, but not in terms of causal chains. And you could put it in a very loose way. You could say, uh, did the universe have a beginning? Well, yes and no. It depends on sort of your reference frame. If we're talking about causal chains, yes, it had a beginning. If we're talking about temporal chains, no, it didn't. Right. So it's a little bit, you could say, kind of dependent on reference frames, and that's why I'm more um, open to uh, something like quasi steady state theory than in the past. I think the Big Bang model and inflation and things like that, I think that's kind of a phase that physics is going through, but I don't think it's going to be in that phase forever. Um, Going to consciousness, and this is something that I do think is a little bit of an original of mine. It's not original to say that the neocortex, which is probably where consciousness is seated, is a recurrent neural net. I believe Patricia Churchland, Paul Churchland, the two of them, I think they've talked about that as well. I haven't read them extensively in the original. I've read sort of secondary sources, but um, the neurophilosophers. Um, but we could say the neocortex or parts of it are uh, probably large scale, recursive, recurrent neural nets, meaning, you know, the neocortex that contains the consciousness could be one large recurrent neural net that's composed of sort of mini circuits or smaller recurrent neural nets. And for purpose of simplicity, I'm just going to refer to that as a Hopfield net, because the Hopfield net is, I believe, the first recurrent neural net that people knew about. Now, and people, you can Google Hopfield net. I'm not going to kind of get into it. Uh, but there's two types of entropy in Hopfield net. There's the hidden state entropy, and there's the output entropy. So the hidden state entropy is basically like the memory. And when I say entropy, I mean the Shannon entropy, and I'll explain that very briefly. You can Google that. But the very simple, non-technical way of thinking about it is, if I have a coin, heads or tails, there's only two possibilities, right? It's heads or tails if I flip it. So it's a very low Shannon entropy, which is basically the space of possibilities. But if I have a six-headed dice, that's more Shannon entropy, because now I have six possibilities and I don't have two possibilities. Okay. Now, if it's a lottery ticket, maybe there's a million lottery tickets. So now the space of possibilities is a million. It's a much higher Shannon entropy. So a lottery ticket has a very high Shannon entropy compared to a dice, which in turn has a higher Shannon entropy than if I'm just flipping a coin. So Shannon entropy is like the space of possibilities, right? So the hidden state of the Hopfield net has what's called a hidden entropy, a hidden Shannon entropy, uh, which means the kind of state of possibilities and the number of states it could be in terms of, very loosely speaking, its memory. It's sort of its internal thoughts or whatever. I mean, this is very loose language, but the hidden state entropy. It's sometimes called internal. I think it's actually hidden state entropy is probably more more common. So we can say the hidden state entropy of a Hopfield net is basically the range of possibilities the internal state can be in, or the hidden state, the internal state. And again, the hidden or internal state of a Hopfield net is essentially like its memory, which of course influences its output state. Um, now there's the output entropy of the Hopfield net, right? And that's the sort of the space of possibilities it could output. So you have basically uh, two types of entropy in a Hopfield net or any kind of recurrent net, neural net. There's the hidden state entropy and there's the output state entropy, right? There's two different things. And by and large, the hidden state entropy will be greater than the output state entropy, and you can tell that intuitively. It's like for any non-trivial nervous system, or maybe even for trivial nervous systems, go down to jellyfish. But the internal complexities are probably more complex. There's more possible states that a jellyfish nerve net, they don't have a brain, but just a nerve net. But I'm sure there's more internal states that a jellyfish nerve net could be in than the output states. The output states are pretty simple. They're moving certain tentacles around to try to grab food or swim or um, copulate and so forth, right? It's a fairly simple set of things jellyfish can do, right? So even at that level, I'm sure that there's more complexity going on inside than is outside, right? So the hidden state entropy of the jellyfish nervous system is probably more, at least in certain conditions, than the output state entropy. So my speculation is that when you're conscious, your hidden state entropy is greater than your output state entropy. So the recurrent neural net in the neocortex, the hidden state entropy is at least equal or greater than the output state entropy. But this is not necessarily always the case. And so when you're unconscious, when you're asleep or whatever, it that internal state entropy is collapsed beneath the level of the output state entropy. Because at some point, and this is philosophers have tried to figure this out a long time, there's some switch, there's some threshold, right? Something happens to my brain when I wake up in the morning, right? Or when I go to sleep. You're never sort of partly conscious. You're completely conscious or you're not at all conscious, even if you're tired or groggy or whatever. I mean, consciousness is, being alive, if you will, that's a very binary thing. You're awake or you're not, right? So there's got to be some threshold there somewhere. So I've thought about it really all my life, and I think just what I've come up with is that threshold is, I'm going to say, the hidden state entropy of the recurrent neural net in the neocortex, or current neural nets plural, but whatever, has to be. But it's probably one big one. Again, you could have a big one made up of smaller ones. It's a scale invariant thing. The hidden state entropy has to be, like, I'm going to call it greater than or equal to, right? The Heisenberg uncertainty principle, delta x times delta p is greater than or equal to h bar, right? The uncertainty of x, the position, times the uncertainty of p, the momentum, is greater than or equal to Planck's constant over 2 pi, which is what h bar is, right? So I'm just going to put a simple thing like that hidden state entropy is greater than or equal to the output entropy of the recurrent neural net uh, of any conscious being, whether it's a human or a jellyfish. And I think that's important, really, ethically, because in the future we might have machines that might be conscious and so forth, and we might be able to determine what is their hidden state entropy. So, if we can see it's above a certain threshold, if it's above that output entropy, um, then that means they are conscious, and it would be unethical to do something injurious to them, right? So there's a difference between necessary and sufficient, or just necessary, meaning um, I don't know that the hidden state entropy being greater than the output state entropy is necessary and sufficient for consciousness, but I think it's at least necessary. Okay, put it this way. So I'm sort of trying to be humble here. I can't prove when something is conscious, but I'm, putting forward a proposal. You could say when something's not conscious. Something's not conscious when the hidden state entropy is less than the output state entropy. And again, by the word entropy in this case, I'm using it in the Claude Shannon entropy, which is just a space of possibilities. There's an old saying that Claude Shannon was coming up with this notion of the space of possibilities for computational systems, and he was trying to figure out what he'd call this concept. And a friend of him told Claude Shannon that Claude Shannon should call this concept he was developing entropy, because he said, this friend of Shannon's said, nobody knows what entropy is. So if you call your concept entropy, nobody can argue with you. Right? So that's a whole deep thing. But anyway, so when the hidden state entropy is greater than the output state entropy, I think you're conscious. So that's my modest proposal for consciousness. And I'm not going to say too much. I don't want to get too much into religion and everything like that here, but I'm going to touch on it just a tad. in terms of my own, I guess, perspectives a little bit. And there's this notion of uh, the Lacanian real, right? And the Lacanian real is the part of human experience that's sort of outside of language. And David Lynch did a lot of this with some of his films, especially with Lost Highway and Mulholland Drive. And of course, it's developed by Jacques Lacan. Um, and there's this notion of the insistence of the real, and insistence meaning something you can't shove under the carpet. So, like an example might be democracy. You can't shove democracy under the cover. Sooner or later, people will revolt. Sooner or later, the college kids will gather in Tiananmen Square, right? That democracy insists to be heard. It can't be swept under the rug. So the Lacanian real sort of insisting, meaning that the reality of the situation will emerge sooner or later. Um, I think Ayn Rand has a similar quote, even though I don't think she was familiar with Lacan, but she talked about you can deny reality, but you can't avoid the consequences that happen if you deny reality, right? So, like if the Titanic hits the iceberg and it hits the five compartments, it's going to sink in a couple hours. Now, you can deny that. You can sit in the stateroom and smoke cigars and drink your brandy. You can deny it, but sooner or later, you're going to be underwater, right? Um, so, that's an example of the insistence of the Lacanian real that things outside our perspective emerge. Now, this happens, of course, in mathematics very much with Gödel's incompleteness theorems, right? I'm not going to get into it too much here, but it's this notion of this axiom cannot be proved. Well, if I prove that axiom, then it's a contradiction. That I have a false axiom in my system, and it kind of blows up. I can't have contradictions in my system. But if I leave that axiom in, of that axiom cannot be proved, I have at least one axiom in my system that can't be proved, and therefore my system's incomplete, right? And then he further later, that was the first incompleteness theorem. He later showed that if you have an incompleteness in your axioms, you get to a situation where you cannot prove the consistency of a system, meaning you can't prove that system is without errors or doesn't have any mistakes or contradictions without reference to another system. So if I have a system of integers, arithmetic, 0, 1, 2, 3, 4, 5, I can't prove that the system of arithmetic doesn't have any contradictions, doesn't have anything that says, this sentence is false without referring to what's called second order arithmetic, some bigger arithmetic system to sort of correct or, invigilate, mark the exam paper, so to speak, of the first system, right? And it keeps going forever. It's an infinite regress of every time I have a math system, I need a bigger math system to invigilate upon the first math system, right? So that's the whole thing with Gödel's incompleteness. And so, with physics, if we have a theory of everything, which we don't, but just for saying we did, say everybody decided one day that string theory was going to be the theory of everything, which I don't think it is anywhere close to having real evidence for it, but that's a separate conversation. But just supposing it did, and we agreed that string theory could unite quantum theory and relativity together, well, that would be a system expressible in math that would need yet another sort of bigger string theory or whatever to kind of correct it and make sure that the first one didn't have any errors, right? So it just, again, you never sort of get to the end. Um, Max Tegmark has talked about this a little bit too. That he says basically there's a relationship between mathematical structures, computer programs, and formal systems. So formal systems have the problems of incompleteness. Um, Mathematical structures have an issue of definability, things like Russell's paradox, and computer programs have the issue of halting, the halting problem. So you have these related things. I'm not going to get too deep here, but formal systems, computer programs, and mathematical structures like set theory in general have deep relationships with each other, and they all have similar problems. Um, Mathematical structures have problems of being able to be well defined sometimes. Formal systems blow up with the Gödel's incompleteness. Uh, Computer programs, formerly known as Turing machines, have issues of halting. In other words, you don't know if they're going to get into an infinite loop or if they're going to return you back an answer, right? It's kind of the computer version of Gödel incompleteness. you're not sure for computers of sufficient complexity. You don't know if it will halt. A funny but true example of this is if I gave someone an assignment, I said for just a typical laptop that you can get at Best Buy, write a program that will print out the maximum number of X's. Say you have an infinite printer with an infinite amount of paper. Print out the maximum number of X's that you can print out without going into an infinite loop, right? So you can't just say while true print X, because that's an infinite loop. Print the most number of X's that you can print without going into an infinite loop. It's something called the busy beaver problem. And it turns out that for computers of sufficient complexity, you can't solve that. So even an off the shelf laptop from Best Buy has sufficient complexity so that you're actually not able to solve that. You can't write a program to sort of maximize the number of X's that you can print out without going into an infinite loop. Because without getting into the weeds, it's been proven mathematically that if you had such a machine, that would violate Gödel incompleteness theorems. You would be back in the realm of this axiom cannot be proved, right? It blows up. Um, so that's an interesting and somewhat humorous thing that however smart we humans are, we can't even tell you the maximum number of characters that your freaking laptop from Best Buy can print without going into an infinite loop. That seems like a simple question, and we can't answer that, right? So there's what you call formal ignorance. There's limits to what we can understand. So going back to this notion of the insistence of the real, and again, Northern Irish theologian Peter Rollins talks about this. So I'm not the first one to say this, but and he talks about God as being similar concept or sort of another way of thinking about the Lacanian real. You have kind of this reality that doesn't always fit into your symbolic systems, into your linguistic systems, into your mathematical systems. Now, I'm not going to get into sort of ad hominem stuff. I'm not going to get into what religion I think does a better job at getting at these deeper truths or whatever. I'm not gonna. I mean, that's maybe a subject of another day. I will say that very often in the history of religion, going back to thousands of years, you've often had an error of sort of a notion of dualism that you have the notion of like you have the physical world, the world of the senses, and then you had this supposedly some deeper underneath world of the numinous and so forth, the spiritual and so forth. Um, and that's a mistake, and that's not what I'm talking about. I'm talking about something that's actually kind of more accessible or simpler in a way. Um, I think it was Wittgenstein kind of made a wry remark. They asked him what he thought of Soren Kierkegaard, and Wittgenstein sort of wryly remarked that Kierkegaard was too deep for him or something. Because Kierkegaard was this mystical kind of thing, person into all this kind of deep stuff. That sort of, again, getting into dualism and stuff. I'm not really an expert on it, but Wittgenstein was much more of a down to earth, practical kind of philosopher. So he kind of joked that Kierkegaard was too deep for him, right? So um, again, I'm not trying to get ad hominem or getting into a pissing match of one school of thought versus another school of thought, but it is the case that uh, when people get into spirituality, they start getting into like, oh well, you have the world of the experience, and then you have kind of a physical world. The truth, at least as I see it, is simpler than this. It's you have the world of the symbolic, you have the world of language, or what Lacan would call the language symbolic. You have the world that we can understand, and then you have the world of raw reality that escapes our ability to describe and to understand. Right. So the world of the symbolic would be sort of the three R's you learned about in elementary school: reading, writing, and arithmetic. Right. That's the world of the symbolic. But then you get into this deeper level, you get into areas like goals and completeness and so forth. You're sort of getting into kind of reality with a capital R itself that always escapes our ability to try to classify it. Okay. So spirituality, I think, is concerned with the limits of human language, and it can be formal ignorance, i.e., it can be, um, you know, where math breaks down, where computer programs break down, but it also could be more um, in everyday experience. So, for example, Slavoj Žižek talks about an imaginary real, meaning when you're watching horror movies, Mulan Drive kind of freaks you out a little bit. I don't want to give too much of away, but it's very into this how the real sort of erupts into day to day experience. There was a scene at a diner where these two guys are in there, and one guy's telling his friend about a nightmare he has about seeing this witch or something. And so anyway, they talk and they leave. It's just an ordinary experience. It's like this diner. It looks like a Burger King or whatever. And they're walking outside, like around the corner of the building, walking to their car or whatever. And then just as they're gonna get to the corner of the building, this evil looking witch suddenly appears in this sort of the black face and a uh, black robe or whatever, just very freaky. And it just Lynch is a master of cinematography, and it just kind of jumps up at you as like a jump scare, right? And then the guy, who is telling his friend about this nightmare that he's having of this witch, suddenly that witch is there in real life, and he falls and dies of a heart attack, scared to death. But that's an example of what Slavoj Žižek would call the imaginary real, meaning in image, not imaginary necessarily in imagination, but images, moving images, pictures, um, in medieval paintings, there would be a memento mori. There would be something that, if you look at it from one side, one angle, it's a skull, but if you look at it dead on, you can't see it. So that's an example of the real in paintings or movies. Uh, so Zizek actually had three reels. He called it the symbolic reel, the imaginary reel, and the real reel, right? So the symbolic reel is, again, things like Gödel's incompleteness theorem, Turing incomputability, issues of how you define mathematical structures, things like set paradox. So that's the symbolic reel. So limitations of language. And then you have the imaginary reel, which is, again, Mulan Drive. Parts of our imaginary experience, images and movies that that are sort of surprising or that we don't expect or we can't predict. That are decentering in some way. Okay, decentering either in just in the sense of a jump scare, or decentering in the sense of it's presenting something in a different way, something that's unknown, or uh, that you don't necessarily uh, would not expect in some way. So it's not just jump scare. So jump scare, yeah, the serial killer and slasher jumping out of the closet, or um, again in Mulan Drive, this witch character showing up in the parking lot of a diner. Um, but then you could have uh, things that are sort of decentering in more subtle ways. So like Harold Pinter's The Homecoming, right? At at the end, um, the basic conceit of the play is this British professor has gone to America, has married an American woman. He's a philosophy professor, and takes her back homecoming to this working class house in North London to meet his father and brothers and uncle. And basically, at the end, one of his brothers, is wanting to uh, essentially hire the wife of this philosopher to be a prostitute, right, and wants to be her pimp and so forth, and she's going along with it. She's quite happy to do this and stuff. And the philosopher guy, okay, he's not really happy about it, but he doesn't really make a fuss about it. He doesn't lose his temper about it, and then he just kind of leaves at the end by himself. And so at the end, this woman essentially becomes, or at least is implied to become, a prostitute um, for the family, and do so very voluntarily. Now, this undermines a lot of sort of polite society expectations of how plays about family and homecomings should be. So, Harold Pinter's The Homecoming is sort of an example of the imaginary real, meaning it disturbs our image of what things should be in polite company. Um, it decenters our expectations on how the world works. And so I suppose there's an overlap between the symbolic real and the imaginary real. But then Zizek also talks about what he calls the real real. And this is not something sort of cerebral, but it's something in kind of in real life, not something you see in a movie or something in philosophy textbooks, but in real life. So you see a UFO or something like that. That's the example of the real real. It's something that's very uh, in your face, very visceral, and you can't get away from it, but nor can you explain it, because if you can explain it, it's not part of the real. The real is sort of the limits of what we can explain. Um, and so that, to me, that's the real dualism, right? And I think the mistake of dualism of saying, oh well, the world of the senses is kind of less important than the world of the spiritual, whatever that's supposed to mean. That's a mistake. The real dualism is the world that we can understand, the symbolic order, and then the world that is sort of transcendent of that understanding. It's still real. It's still something apprehendable by our senses. It's still part of the physical universe, but it's not something that we can grasp in some way. Um, but it's always there. In other words, there's always limits to our understanding. There's always limits to our language. And so I think that's really what spirituality is about. Is it's about, at least in part, it's about coming to grips with the limits of our understanding. Again, I can't know how many characters my laptop can print out without falling into an infinite loop, right? Um, that's an example of that. And there, there's a moral or ethical dimension to it. Ethical is sort of the uh, mores or how we should behave with respect to others. Like paying my taxes is ethical. Morals is like more of a personal choice. So I fast on Yom Kippur because I identify with Jewish culture, and so that's a personal choice I make. But it's not something I can foist on others. So morals are like personal choices we make, like fasting on Yom Kippur. Ethics is how we behave with respect to society. So paying my taxes is an ethical thing, right? Because it is how I relate to society. Fasting on Yom Kippur, that's more of a moral thing. It's a personal thing. Okay. Um, uh, in the Decalogue, the 10 sayings, it's actually not 10 commandments, it's 9 commandments. But Christianity kind of breaks the first commandment of no other gods before me and no images. That's really one commandment, right? But they kind of chop it up into 2 commandments because 10's an even number, right? But in Judaism, it's actually 9 commandments because that first one is just no gods, and while we're on the subject, no images. It's kind of one thing, and the first sentence is not a commandment; it's a saying. I'm the Lord thy God who brought you out of Egypt, um, out of Mitzrayim, out of Egypt, right? So anyway, that's a side note, but it's called the Decalogue or 10 sayings, right? Because the first is not a commandment; it's just I am Adonai or the Lord, however translate that. I'm Adonai who brought you out of Mitzrayim, out of Egypt, and then on the second saying, it's getting into the no God. So anyway, it's 10 sayings, one saying, one just declarative statement and 9 imperative statements, or in Judaism, or in Christianity, 10 commandments. Um, but the first 5 of those, or 4, I guess, depending on how you're doing the counting again, are kind of morals, right? It's how Jews should behave, and then the last 5 of those sayings are more ethical, kind of in the broader world. So, in other words, don't make images. Uh, uh, don't take the name of Adonai in vain. Keep the Sabbath day. Honor thy father and thy mother. Those are for Jews. It's not expected for others to do that, or for non-Jews to do that. But don't kill, don't steal, don't commit adultery, don't bear false witness, don't covet. Those are ethics. Those are universal things, whether you're Jewish or not. You're supposed to, follow them. So there's a difference between morals and ethics, and that's a diversion. Um, but whether we're talking morally or ethically, we're talking about the insistence of the real. That has an ethical dimension, um, because we're all kind of in that same boat, right? We're all in the same leaky lifeboat. All of us are subject to goals and completeness, right? None of us can get. I don't care if you're Stephen Hawking, right? There's limits to human understanding. We're all subject to the insistence of the real in one way or the other, right? Nobody's special. Nobody's above anybody else, and so we have to treat each other with kindness, right? Because we're all in it together. We all rise or fall together. Or we're all equally screwed if you want to be a pessimist about it, right? But there's an equality there. There's a shared fate there, and so therefore, spirituality has an ethical dimension when viewed as being the insistence of the real. So yeah, just a quick video. I wanted to kind of cover those big topics of cosmogenesis, consciousness, and spirituality, and just my opinion on that. So thank you, and have a nice day.